Okay, welcome Trinity Classical Academy to our very first stab at a video class instructional section. I am, of course, your host, Mr. Bourgeois. I am really excited to do this. I've been messing around with video for a little bit and never quite got it to work. But what do they say? Necessity is the mother of invention, or something like that. I had to figure out how to make it work now. So a little bit of sense of urgency got the fire under my butt, and now I figured out how to make the videos work. So I'm using Microsoft Whiteboard. I think it's a really cool tool for recording. I'm also using the Xbox recording app, in case you cared. You probably don't. Just so one of the things that I feel like we're going to miss, just kind of an overview of how this video remote thing is going to work. Some of those spontaneous things that we're going to have that we ordinarily have in the classroom, where curiosity provokes question, provokes dialogue, that's going to be a lot more difficult to manage, and so that's going to be a little bit sad. There are some other implicit advantages to this kind of a format, but so just as a quick overview, so if you have questions, this is point number one. If you have questions, just go ahead and pause the video, jot down your thoughts, your concerns, your questions, things you want addressed. I want you to know I can't see you, and so don't raise your hand and wait to be called on, right? So put your hand down, Josiah. That means you. And there will be times when ordinarily in the classroom we would be using a whiteboard, right? You'd have the lap board, and I'd say, okay, let's take a look at guided practice number 3. Everyone give it a shot. We're still going to do that, and how we're going to do that is you're going to pause the video. I'm going to tell you to pause the video. You're going to do it. You're going to pull out your scratch paper. You're going to work the problem as best you can. You're going to scratch your head and maybe be confused as best you can. And if I want you to work without that pressure of, oh my gosh, the person next to me did it in 6 seconds. Why is this taking me longer? Don't worry about that, right? We're never supposed to worry about that. But hopefully with the video format, it will be easier to kind of tune out the noise and just work at your own pace. And then when you're ready, push play again, and then you'll see a solution worked out. Now, if by chance you found another way to solve the problem, this would be a time in the classroom when you'd say, Mr. Bourgeois, may I make a suggestion? Or I did it a different way, or some of those organic things would happen. Again, pause the video, jot it down, say, hey, I solved this a different way, or why can't we solve it like this? Why does this not work? Stuff like that. And also, I'm going to put little tags like this one, and I'm going to put little tags like this one. It's going to be like, hey, we're on this page. So I want you to follow along in the pages. I can't, it goes two ways. I can't see what you're doing. You can't see necessarily where I am. And so hopefully we don't get lost with each other. So that is the meta conversation about video format. Presently, let's jump into chapter 6. You should be in book B for your course 2. So if you're in book A, you're in the wrong book. Also, if you're not in 7th grade, you're watching the wrong video, just so you know. Yeah, so I'm really excited, you guys. It's so good to see none of you. I mean, wait, you know what I mean. Well, open up your books to page 3 or 2. We're going to look at kind of the attributes of angles, and probably many of you who are in sports or in dance, you work with angles on a regular basis. The angles have a big effect, and thinking about angles can make things very different. So this would be a good time if I was like a professional video editor to put in like flash up some little pictures, but I don't. So check this out. So on the topic of angles, my ruler functions as a protractor as well. So if let's suppose Mr. Bourgeois is doing push-ups. There he is. Look at those beefy muscles. So Mr. Bourgeois is doing push-ups. If I want to make the push-ups more difficult, I can actually elevate my feet. I can wear my shoes. It puts the angle different, right? This is the angle. Maybe I should have done that in a different color. I'll try to get good at color here. There. So this is my angle. These are my feet, right? Feet. That's my head. As you can tell, these are my arms, and that's my beefy bicep right there. So, so as I'm doing push-ups, I'm training the ordinary way. Of course, I'm never at an angle like that because my arms aren't that long. So if my arms are shorter, then really it probably looks more like this. Let's see. A little less of an angle. Let's try that again. There we go. Short little stubby arms, still beefy biceps. Those push-ups are more easier. The lower I get down to the ground, the more difficult the push-ups get. And if I go down on an incline, or a decline, excuse me, if I go down on a decline, push-ups get more difficult. If I go up on an incline, I'm supporting more of my weight because gravity's pulling me in this direction, straight down. So the more down I go, the more gravity I'm resisting. The example in your book, we can read it out loud, or you can pause it and read it, about the launch angle. So with that, goodbye, Mr. Bourgeois doing push-ups. So with the launch angle, you've got your basketball hoop. They're saying that shooting the basketball, short dudes generally do better with free throws because they have to arc it higher, which makes it more likely to go in the net than Shaquille O'Neal, who's more of a line drive kind of a guy. He's always been famous for being so bad at the free throw line because he's so tall. It's harder to get that same arc on your shot. So that's just an interesting way that the math book likes to get us involved in the topic using sports. They're being relatable. So looking on page 3, I want to let you know chapter 6, this whole chapter on angles is going to be extremely vocab intensive. We'll do this. Vocab. There's a lot of vocab in here in this chapter. For the next week, you're going to be learning terminology, and you'll need to know that terminology really well. This page kind of introduces you to some stuff that they say is supposed to be review. If it's not review, then just learn it. So we have the acute angle, and I remember the way that one of my teachers helped me to remember what acute means is that it's cute because it's little. All right, how do I do this? Beep. There it is. How can I bigulate this? Bigulate. I don't know if it'll let me change the size of my typed words. Acute. It's less than 90 degrees. How do I do the degree sign, I wonder? I'll have to look that up later. We won't waste time now. Less than 90 degrees. That's as close as I can get. Maybe degrees. We'll say that's degrees. It's cute because anything small is cute, obviously. The 90-degree angles. 90 degrees are widely used in making, things like houses and squares and anything else that needs a 90-degree angle. It's called a right angle. Makes a square. Because if it's not right, it's wrong. Then there's obtuse. Obtuse is bigger. I think the root is ob. I think it's the word that we get obese from. I'm going to just go out on a limb and say yes. Just remember that ob means bigger. And then of course there's a straight angle, which is just a line, but it's important to think of that as an angle. It's exactly 180 degrees. This is bigger than 90 degrees. Ob means big. So hopefully this vocab makes sense. So this is review vocabulary. It's important that we remember that a right angle is exactly 90 degrees, a straight angle is exactly 180 degrees. You put two right angles back to back, you'll get a straight angle out of them. Make sense? That's going to be important moving on. Let's turn the page. Page 4. I'm gonna skip the quick checks on page 3. So page 4. So at this point in the video, we are on page. Actually, let's do this. We'll move down. All right, wake up, guys. All right, you. The good thing is, I think I learned how to edit videos. There we go, page 4. Boom. You guys have the ability to rewind, so if I erase something, no big deal, right? So, there are different markings that will be used in the book to identify lines that are parallel and perpendicular. Here's more vocab. Parallel, look at how that's spelled, a double L and then a single L. They will never intersect. Side by side, running together forever. Perpendicular. They intersect and form right angles. All right, so here we are. We're back at vocab. Oh, that's neat. It snaps it to place. So when we have parallel angles, they will mark it with, or parallel lines, I should say. They will mark it with a little symbol dilly. So these lines are perfectly parallel. If I continue them forever and ever, they will never, ever, ever intersect. And so they do this thing here where they say point you can see this in your book, right? So they label the points, and so this one is point A, point B, which makes this line AB, and they put a little swiggle on it. And over here they have C and D, and they put the same little arrow swiggle on it, because these two marks are, pretend they're identical in your book. They're showing you that, hey, these two lines are parallel to each other. Now, if they sometimes will do something like this, where they'll continue on, and they'll have two different lines in the same figure, they'll usually do something like this. They'll put a double mark on it to show that, hey, these two lines are parallel to each other, and these two lines are parallel to each other, but not parallel to these lines. Make sense? Fun times. All right. Erasifying. And then what they do when there is a perpendicular line is they'll do a different symbol. Nope, that one. They'll do this symbol of this little square thingy. They'll do that. It's supposed to be like a perfect square. Let me try that again. supposed to be a perfect square. That means, hey, the intersection of these lines is forms right angles. This angle is a right angle. And we always know that if this line is intersecting this one and this one, we'll get to this later, but that's called a transversal. You don't need to memorize that now. Later chapter. Very cool. Guys, do the quick check on the bottom of that page. I believe, let me double check. I believe if you pause the video now, I don't know what color this is, go ahead and pause the video. Pause the video and try the quick check problems really quick. If you can identify the parallel lines and if you can identify the perpendicular line segments, I should say segments, because they're not lines, they don't go on forever, they are segments, they stop. And I'm going to check, we'll see if the answers are in the back of your book. I do not believe they are. Okay, so hopefully you paused and looked at them. I'll just give you the answers right now. Number 7, line segment RS and UT are parallel. Line segments WX and ZY are parallel to each other, and also WZ and XY are parallel to each other. That's 7 and 8, quick check. Number 9, ABCD is a rectangle. Therefore, we know that AB and AD are perpendicular, as are AB and BC, as are AD and DC, and BC and DC are both perpendicular to each other. In the right triangle, we see that little square symbol there. GF and EG segments are perpendicular, and then we have two pairs of perpendicular lines in figure 11, which is a trapezoid. IL is perpendicular to IJ, and IJ is perpendicular to IK. Fun times, you guys? Fun times. Here we go. So now starting on chapter or 6.1. So 6.1, you guys, is going to have more vocabulary. And this vocabulary, I feel like as long as you memorize the vocabulary, you're going to do just fine, because then it becomes arithmetic at that point. So notice the spelling. So you should be on page 5. So wake up, everybody, you're on page 5. If you like, the other cool thing about video format, just as an aside, if you find yourself just really drooping, push pause, do some jumping jacks, and then push play. I mean, this is like ADHD heaven. Oh my goodness. All right. I hope you guys don't love this too much, because you're going to have to eventually go back to the classroom. So, all right. Come on, tool, don't fail me now. There we go. All right. Moving on. What does this do? Note. Maybe I could do that. Ah. Yeah, we'll play with that later. Trash. All right. Okay. First, complementary angles. Complementary angles, spelled with E, not complementary. A complementary angle thinks your hair looks really cute today. A complementary angle forms a 90-degree angle with its complement. Look on page 5 at the enthusiastic math student who says, angle ABC is called the complement of DEF. DEF is also called the complement of ABC. They are complements to each other because when you put them together, they form 90 degrees. A right angle. Right angle. So the vocab word of the day is complement. Whenever you hear it, yell real loud. Ple. Complementary angles form a right angle together. So you see that a 30-degree angle plus a 60-degree angle makes a 90-degree angle. It's just that simple, you guys. 30 plus 60 equals 90. They are complementary. One angle is the complement of the other. Also notice the nomenclature that they use, or how they name angles. They'll give you points, A, B, and C, and those points are used to label the angle. So we have, if this is point A, that's point C, and the vertex would be point B. Use my fine tip. A, point B, and point C. And perhaps these are even a ray. Perhaps these are even rays, so they go on forever. It doesn't matter. At some point, we have A, the point on this ray, ray BA, ray BC. So these are two rays intersected here. And we call this angle ABC. Easy as pie, right? Also, I want to make a note here. Anytime we're talking about an angle, this middle letter right here, this little middle point, is going to be the vertex. That really helps us to identify and distinguish one angle from another. And that's going to be a good habit to get into, is that you name your angles like that, because it makes things more clearer. So complementary angles add up to 90 degrees. So here we have ABC. I'm just going to kind of duplicate what I see in the textbook. And then over here we have freehand, loosely drawn. We have D, E, and F. So this angle measures 30 degrees. This angle measures 60 degrees. You add those two together, and you will get, that looks like crap. Now add those two together, and you will get 90 degrees. Make sense? I think I did a pretty good job. I think that 60 looks exactly twice as wide as that 30. And I think together they look like they might almost make 90 degrees angles. Maybe not. It's okay. I apologize, you guys. I was anticipating that we were going to be in the classroom for this lesson, and I had protractors for everybody, and you guys don't have protractors at home. What that's gonna mean is you're gonna miss kind of the hands-on stuff. So this is a timeout. If y'all at home desperately want to do the hands-on activity on page 6, you can beg your parents to dig out the protractor that they bought for one of your siblings, or you can run to Walmart, and I don't know if there's any protractors left. With this coronavirus, everyone's trying to grab as many protractors as they can, because you never know. You never know. You might need 6 protractors in case you get a cough. But you might be able to find a protractor at Walmart, and they're like a couple of bucks. So if you really want to measure your own angles, you can do that. We're on page, so that's on page 6. It's actually, page 6 talks about not protractors, but using geometry software. I don't even know what that is. I've never heard of such a thing until I looked at this textbook. So once again, if you want to use geometry software, knock yourself out. I mean, you are in charge of your own destiny at this point. Now, page 7, moving on. Page 7. I wish I could make this bigger. Can I bigulate this? I've been trying to do so much I've been trying to do so much different stuff with this software, and it's really helpful for a lot of things. But oh, you're not even gonna let me use the eraser? Fine, be that way. All right, example 1, identify complementary angles. We're on page 7. Wake up. Complementary angles, any two angles whose measures add up to 90 degrees. That is a right angle. They are complements to each other. So look at the solution. Since M, so the solution is like this. On the top, we're on the top of page 7 again. Since M, angle ABC, M stands for the measure. The measure of angle ABC equals 66 degrees. And the measure of angle DEF equals 24 degrees. That adds up to 90 degrees, which makes them complements. And it continues. It says GHI and MNO are complements, and JKL and PQR are also complements to each other and no one else. Because in order to be a complement, you have to add up to 90, not 90.5, not 89.7, but 90 degrees. Sweet? All right, here's a point where we, oh cool, it leaves it big. Pause the video. Pause the video. Try to do guided practice number 1 at the bottom of page 7. Ready, set, go. Okay. Since you hear my voice, I assume that means that you have found the complements on the bottom of page 7. Here they are, in no particular order. Angle ABC and PQR are complementary angles. DEF and MNO are complementary angles. And GIH and JKL are complementary angles. Those are the 3 pairs of complementary angles. Just so you know, guys, here's another bonus. Complementary angles, they have to be 2 and only 2. You can't say there are 3 or more angles and they are all complementary together. It doesn't work that way. It's like a marriage. There's only 2 so far. We'll see what happens. But yeah, 2 and only 2 angles can form a complement, can be complementary to each other by definition. That's how we're doing it. Toot sweet. Moving on. You know what? I can also go this way. Maybe I'll do that. I'll have a massive whiteboard. Next. Now, turn to page 8. Page 8. We are looking at the example 2 on the top. It says find an angle measure involving complementary angles. This is still pretty simple arithmetic. It says if angle P and K are complementary, but we don't know what the measure of angle P is, find out what its measure is. So, I mean, it's kind of like algebra. So we know that, maybe I'll keep one color that's set to medium. We'll try that. What color are you? Red, blue, okay. So, blue pen will be my go-to writing pen. We'll see. So algebra, so we know that the measure of angle K plus the measure of angle P equals 90, because they told us it's complementary. We also know that angle K is 19. So then 19 plus, we'll call that P, equals 90. We can figure out by subtracting 19 from 90 what angle P is. And it would be 71. Spoiler alert! Righty-ho. If you guys feel like you want to do guided practice 2, which figures out the missing value of a complement, go ahead and do that. That would mean that you should pause the video. That's the symbol for pause the video. When you see that, pause the video and then replay it later. Cool? Cool. All right, so you've paused the video, you've worked out guided practice number 2. Here are the answers going down from the top. The measure of angle B in the first row is 62 degrees. Second row is 17 degrees. Third row is 54 degrees because you subtracted 36 from 90. And and the third row, you take 90 minus 15 equals 75 degrees. Make sense? Groovy. So supplementary angles. Supple means either adaptable or flexible and fluid. So supple, like when they talk about like supple skin, it means your skin has lots of elasticity to it. Hopefully that helps you remember supple means one big straight line. Imagine a person doing the splits. They are very flexible, right? Like a supplement adds flexibility to your diet. So supple is two angles that are supplements to each other make a straight line, make a 180 degree angle. And you might have heard the term doing a 180. So if I'm facing one direction, let's say I'm facing north, this is me with my mustache, and I'm looking north. If I do a 180, it means I'm turning around and now I'm facing the complete opposite direction. That is a 180. If I then do another 180 and I'm facing my original direction, I have done 360 degrees. 360 degrees makes a complete circle. That is a fun rotation, you guys. One very fun rotation. I feel like I need more eyeballs. I look like an evil twin. So that is my evil twin then. Okay, so supplementary angles, you guys. Supplementary angles, just like complementary angles, they are two and only two and exactly two all the time two, whose measures add up to exactly 180 degrees. Always exactly 180 degrees, with no exception whatsoever. So looking at exploring the properties of supplementary angles, you see just like the previous example, this enthusiastic math student is saying angle PQR is called the supplement of angle STU because they add up to 180 degrees, and conversely, STU is called the supplement of PQR. They are supplements to each other. Isn't that sweet? It's precious. Oopsies. I got rid of my page 8. Make sense? Cool. Oops, not that. I want this. So guys, now, edit, we are on page 9. Actually, no, just kidding. Haha. Page 9 is another technology exercise, which you may read about. It's kind of fun. Not really. I mean, you might think it's fun if you like that kind of thing. Moving on to page 10. Again, you can always pause and take a break, because I don't want you sleeping in my class, because I can't slam a book down on your desk. That's right, I'm talking to you, Sadie. Sorry, I just picked a random name. Wake up, Johan. There you go. All right, page 10. Tell whether each pair of angles is supplementary. Well, just like we did with complementary angles, we look to see if their measures add up to the target number. In this case, the target number is 180. So the measure of angle A is 96 degrees, and the measure of angle B is 84 degrees. Are they supplements? The answer is yes, they are a pair of supplementary angles because angle A and angle B are supplementary angles because their measures add up to 180. Again, I'm being very intentional about my vocabulary. Their measures add up to 180, so the angles themselves are supplements to each other. Question B. If the measure of angle C is 16 degrees and the measure of angle D is 74 degrees, are they supplements? Hang on, those add up to 90. So yeah, they're, oops, no, that would be complements, not supplements. Like I said, vocab, super important. Angle C and angle D are not a pair of supplementary angles. See, enthusiastic math student? He goes, because they're complementary, they can't also be supplementary. Boom shakalaka. And then the number C. The measure of angle I is 36 degrees. The measure of angle J is 164 degrees. You add those together. Do you get 180? You do not. You get 200. Therefore, they are not a pair of supplementary angles. Here we're going to pause. And you're going to do guided practice. Yes or no? Guided practice number 3. Is each pair supplementary or not? Ready, set, go. And we're back. So A, no, not supplementary. B, no, not supplementary. C, no, not, or yes, supplementary. And D, yes, supplementary. Basically, you're just answering the question, do these add up to 180 or not? That's it. Fun times, you guys. All right, now we're on page 11. Boop. Wake up. Wake up, my thing. Whoa. That's crazy. I didn't know I could do that. All right. Page 11. Here we go. Find an angle measure involving supplementary angles. We already did something just like this with complementary angles, where you're finding the missing value. So you're looking at it saying, hey, so if I know that angle K has a supplement called angle P, and I know the measure of angle K is 22 degrees, what is the supplement? I take 180 degrees. We're going to pen this. I'm just going to freehand it. Here's angle K. Angle K is 22 degrees. That's actually much, much larger than 22 degrees. Let me try to make this to scale. 22 degrees would be something like this. It's really pretty. I think that's good. So we're trying to find the measure of angle this one. We're trying to find this measure, which is angle P. I kind of cheated and introduced a new concept, but they're also adjacent. We'll get to that later. So 180 degrees minus this 22. If I know that this is 180 degrees, let me try that in a different color. If I know that this is 180 degrees, what is going on with this color? Is it like rainbow? That's ridiculous. We're not doing that. Well, maybe we will. We'll keep it rainbow. It'll be fun, you guys. If this is 180 degrees, I can subtract 22 from it to find out what this value is right here. Question mark. And I will get an answer that is 158. 158 plus 22 equals 180. Angles are really fun to play with like that because it just works that way. Isn't that neat? I think it's neat. I could be alone. I don't know why this one is still getting stuck. I feel like my maybe that worked. Okay. Groovy. All right, here we go. Pause to do guided practice number 4. All right, you're probably unpaused by now. Guided practice number 4. Here are the answers. If you did not get these answers, you can send me a message through, Student Square. And actually, I just realized I think I told you to jot down your questions, and then I never told you when to submit the questions. You're going to I put this in the instructions that was sent to your parents. You're going to send all your questions. I have office hours. I'm going to try and maybe see about doing a YouTube live stream. We'll see how that goes. But otherwise, I'll just answer the questions in some kind of an email blast, a Student Square blast. I want everybody to have access to all of the questions and answers that get asked. So if you didn't even think about a question, but Cam or Addie or someone has this really great question that's like, hey, well, but what about this? And that's just amazing. And you're like, oh my gosh, I didn't even consider that. I want that to be available to everybody in the class. So please send me your questions. And if you want it to be anonymous, I suppose I can allow it to be anonymous, whatever, maybe not. But that way we can all benefit from your thoughtfulness about the material. It might to some of you seem that like this is new. It might to some of you seem like this is old review. Wherever you're at, hopefully curiosity will prevail. You'll be thinking about this material in a in an engaging sort of a way, and everybody will benefit. I really don't want us to miss out on the on that classical element, that dialogue, the dialectic element of what we try to do here at TCA, right? So please send me your questions, Student Square. If I do a YouTube live stream, you could also leave comments on the video. Perhaps, I don't know. I'm not really proficient at YouTube. I'm still learning as I go, so we'll see. But we're still on page 11. We're doing this new part. So, new section, explore the properties of adjacent angles. If you'll notice here, I kind of cheated a little bit and I did my angles all together right here. Honestly, I think that 22 is a little bit small, but adjacent angles, everybody read, explore the properties of adjacent angles, bottom of page 11. When two angles share a common vertex and side, but have no common interior points, they are called adjacent angles. And they give you some pictures down there of what that looks like, what that means. Like they give you the words and that seems really weird, but then when you see the picture, you're like, oh, I get it. Adjacent angles are next to each other. They do not overlap each other. So they are completely adjacent, no overlap. Some examples of adjacent angles are shown. So the first one on the left, angle AOB and angle BOC. Notice the O is common between the two of them. It means they share a vertex. They share a side too, which is the ray OB. The middle one, angle DOE and angle EOF, are adjacent angles that share the ray OE. And the next one, they form a straight angle. Angle XOY and angle YOZ are adjacent and share the ray YO. Notice the angles are always going to have the same middle letter, the same middle point, and the last letter is always the first letter of the next angle. Make sense? I mean, I suppose you could technically word it the other way. So like if you look at the middle one, angle DOE and angle EOF, I could also call them angle EOD and angle FOE. I could word them that way. I think generally though, when you read the angles, you generally go top to bottom, left to right. But as long as you're clearly identifying the vertex as the middle letter, you'll see that that is one that's always in common. Fun times, you guys? Turn the page. I'm having a lot of fun. I hope you are too. Won't you be my neighbor? We're on page 12 now. In case you were wondering, yes, I'm still weird. Righty-hoo. Here they get visual. On the top of page 12, it's the same concept. This is just what we were doing just a second ago with complementary angles. They're just also adjacent. So instead of having an angle here and then another angle here, they just smushed them together and did like this and made them adjacent angles. Oh, check this out, you guys. I'm going to play with it. Because I have a toy, I'm going to play with it. I can do this lasso tool. Come on now. Why you no lasso? I was doing this just before. There it is. And I can force them to be adjacent. Haha, you're adjacent now. I have so much power. Yeah. Okay. Sweet. Righty-ho. Okay. Enough playing. So then they say, hey, if I gave you the measure of this angle is 41, you should be able to figure out the measure of this angle if I also tell you that this angle is right. So I say, let's add points to this. So this is point P, This is the vertex Q. This is point S. And this is point R. And these are technically all rays. So they continue on forever and ever and ever to infinity. So we know that, so if I tell you PQR, or excuse me, PQS if I tell you PQS is 41, and if I tell you that PQR is a right angle, then you should be able to take, so measure of angle PQR is 90, and the measure of angle PQS is 41. I should put equal signs there. It gets a little messy. This would be easier with an actual marker on an actual whiteboard. You should be able to find the measure of angle SQR by subtracting these. Righty-ho? We should be able to see that it is 49 degrees. Super fun, you guys. It's the same thing we did back on page 6. So literally half the book ago. Or actually, it's more like it's more like what we did on page 7 and 8. But now it's visual, and it's easier to see because the angles are adjacent. They're formed by 3 rays instead of formed by 4 rays, because they share a common ray, or a common line segment, or a common line. But we'll get to lines later. Everybody, pause. Pause the video, do guided practice number 5, ready, set, go. All right, hopefully you got it. Here's the answer. So it says in the diagram below, measure of angle ABC equals 90 degrees, therefore find X. X, as you see in the diagram, is the measure of angle ABD. We already know that DBC is 23 degrees, so we can set up the problem. We know that 23 plus X equals 90. We also know that if we subtract 23 from both sides, we can get X equals 67. It's doing it algebraically, but you can see that just you're finding the missing value. In case you're wondering, hang on a second, does this also work with supplementary angles? I'm glad you asked, Cam. It sure does. Supplementary angles work in a very similar fashion. If we have angles that form a straight line, we know that their measures are going to add up to 180 degrees. So now we are on page 13. Whoop. Page 13. Explore the properties of adjacent angles on a straight line. In the diagram below, angle XOY and angle YOZ are adjacent angles on a straight line. Line XZ is the name of that line. Notice that XOZ is a straight line. So angle XOZ is a straight angle because it's the same as a line. It's line XZ. Therefore, the measure of angle XOY plus the measure of angle YOZ equals 180 degrees. At this point, a thought just occurred to me. I've been going at it for almost 50 minutes, and I'm concerned that maybe my computer won't be able to handle recording a video too long. And if I lose this entire recording, I will be very sad. I'm going to try to stop it and splice another video on top of this. I should have tested this first before I got into the meat of it. I'm going to do that. stop it. We're going to have a video B come up because I don't want this video file to get too gigantic. Here we go.